Okay, let me just start review what we have done on Tuesday, okay? And then today I will give you one more example and then we move forward to the next topic, okay? So last time I talked about the method, which is called Newton method. This Newton method is the method to solve the system of linear equation or even one equation. If you remember that we studied before the midterm exam, okay, the Newton method. So when we derive the Newton method, we try to solve the problem, say that f of x equal to 0 and f of y equal to 0. This is the problem that we want to find, okay? I give you only 2 by 2 equation. And in general, this system can be extended to 3 by 3, 4 by 4, or maybe hundreds by hundreds, okay? So just for simplicity, I start with 2 by 2, 2 equations and 2 unknowns, okay? So when we have this, and I think that for the exam, it might be 2 by 2 because we do it by hand. You have to show me steps, okay? Which we need to solve for the system of linear equation. First, we rewrite the problem that we have in such a way that the right-hand side equal to 0. Once of that, we find what we call the Jacobian matrix. Okay. And the Jacobian matrix is just the matrix which the element is just the derivative with respect to all the unknown. So the first equation with respect to x and y, second equation with respect to x and y. So this is the partial derivative. Okay. If you have 3 by 3, like this, 3 equations and 3 unknowns. You will try to solve this system by take the partial derivative. Since here you have f depend on x, y, and z. Okay, so you take the partial derivative of f with respect to x, f with respect to y, f with respect to z, and the second row you use g, take derivative with x, y, and z. And the last equation, you take derivative with x, y, and z. So you have 3 by 3 as the Jacobian matrix. Okay. This is for any number. But after that, after you got the Jacobian matrix, the Newton method is just you solve this system. Okay. Jacobian matrix. It means that you have the initial guess. You make a guess about your solution. You have what we call vector x0. Sometimes I put the parentheses, sometimes I didn't, but everybody had to understand the same thing, that we have initial guess. You set up the system by use this formula for this Newton method, Jacobian matrix. Replace x, y, and z, the unknown, by initial guess. The right-hand side is the function minus of each function. Replace it by x, y, and z by your initial guess. And then you solve for what we call delta x. It's the difference between xn plus 1 and xn. Okay? The one previous and the current one. You keep doing this until your function close to 0. Okay, your function close to 0 because we start with solving the equation equal to 0. Okay, so we want the solution in that way. So let me just show you one more example of how to solve this problem. Okay. Suppose I want to solve Okay, if I write this, it means x0 is 1 and y0 equal to -1. Mean the same thing, okay? So for this, if I want to solve these two equations, x and y, okay, for x and y, so I will say that the first equation I call it as my f. This one I call function g, okay? The first step, I will find what we call the Jacobian matrix. Jacobian matrix is gonna be the 2 by 2. So it's gonna be the df by dx, df by dy, dg by dx, dg by dy. Okay. So what is the partial derivative of f with respect to x? 3x squared, right? Derivative with respect to y is 6y. dt by dx is 2x. dt by dy is 2. When you take the partial derivative with respect to x, you treat y as a constant, okay? If you take the derivative with respect to y, you try to look at x as a constant, as a number, okay? So you will get the Jacobian matrix. Now, you try to solve by using the j vector x at the end step time vector delta xn equal to minus f evaluate at xn. Okay. In this case, I say x, initial case is 1 and -1. What is jx0? You replace x by 1. Replace y by -1, okay? X is 1, we plug in 1 here, y by -1, 1 here. So you will get 3, oops, 3 times 1 square, 6 times -1, 2 times 1 and 2. So what is f of x0? 1 to the third plus 3 times -1 squared minus 21. And g is gonna be 1 squared plus 2 times -1 plus 2. Okay, so you replace x equal to 1 and y equal to -1 in this function f and g. Okay, f and g is that. So you will have this part. So it's gonna be what? -21 plus 4. So it's going to be minus 17. Okay. And then 2 minus 2 plus 1. So on the right hand side is 17 minus 1. So I will use Cramer rule for delta x, okay? One point five five five, okay? And delta y 0. Okay, so we know the determinant of the denominator. So we get you get delta x 0, delta y 0. ค่ะติดหรอติดลบถูกต้องขอบคุณค่ะเอา3 digit แล้วกัน โอเค but delta x is x1 minus x0 y1 minus y0. Okay, what we want to find x1 and y1. So x1 is 1.556 plus x0 is 1. So you get 2.556. And y1 is minus 2.056 minus 1 is plus 1. Oh, plus minus 1, sorry. So it should be plus of minus 1. Okay. is gonna be minus 3.056. So this is just the first step, okay? So now we have to check if we plug in x1 and y1 into the equation f and g. So we plug in, we find what is f x1, okay? So we will have x1 is 2.556. The equation is x1 to the third plus 3 times x times y. Okay. And x1 squared. Times y. Okay. And then you get this one is not close to zero. Okay. This one is not close to zero. You do the next step. Okay. So you calculate Jacobian of x1. Jacobian is 3x squared. 456. Okay. So we solve this. Minus f Okay, so this is how you do it, and you will solve and you will get delta x1, delta y1. Delta x1, you will get delta x2 is delta x1 plus x1, okay? Y2 is delta y1 plus y1. So whatever you solve for delta x1, delta y1, you add delta x1 and delta y1 with x1 and y1. You will get x2 and y2. And you keep doing this, okay? When you will stop, when the maximum of f and g less than epsilon, maybe 10 small number. Something like this, okay? You keep doing the same procedure until you get the final result. But for exam or the practice, I will ask you to do just only 2 or 3 steps, okay? But in general, you might have to do so many times. So for this problem, if I say I want the solution less than 10 to the minus 9, okay, I do the calculation and I put okay. So here they do, I run the program, I didn't do it by hand. I wanted the solution is accurate so that delta x, delta y less than 10 to the minus 9. So the solution would be x1 is 1.654 and x2 is minus 2.34. But actually you might do only, if you want just only 2 digits, okay? 1 or 2 digits. Roughly speaking, you might do only like 3 or 4 times, okay? Only 3 times or 4 times. You can see the details here that, okay, 1.6 minus 2.35. And you can see that is quite close to each other, okay? So you might just say, roughly speaking, the solution would be 1.66 or maybe 1.64 and minus 2.34. Yeah. So this is just, you want to write a computer code. You don't want to do it by hand, okay? Okay, so here this is what you can do when you have this kind of problem. Oops. Maybe next page. Okay. All right, so far you guys already have learned how to solve the system of linear equation and the system of nonlinear equation. Okay. So the part from now on is gonna be more theoretical. Okay. I only teach you that when we have the equations, how we solve the problems. Okay. But in general, I told you that for the system of linear equation in linear algebra, okay, what I'm gonna go here is called the linear algebra subject. Okay, it's one of the big subject, but I will get involved in this class just a little bit. So you can see that in the mathematics point of view, in general, we can see only something up to 3Ds, 3Ds, okay? So 2Ds, you might think about where the line cut each other. This is the system of two equation and two unknowns, okay? So this one, but also we want to see where the plane touch each other. One plane, two plane, three plane, or something like this, or we have three planes, okay? But it's more difficult to visualize, okay? And if things move, I will say that if things move, it also involves with time, okay? You have some point X, Y, and Z and move with time. We talk about 4 dimension, okay? 4 dimension. When we talk about vector, we talk about vector X, for example. X is can be described in 2 direction if we talk about in 2D. Okay. In mathematics, we call it in R2. Okay. If we talk about something which involve in X, Y, and Z, okay, we can say that this is in R3. So in the 3-dimensional object or something like this, okay? But how can we extend from 2-dimensional problem to 3-dimension, 4-dimension, and in physics, they talk about n-dimensional problems, okay? And that you have seen it before as we solve the n equation in unknown. It's when you have so many dimensions. You might have hundreds unknown, hundreds equation. You can think about that you have 10-dimensional object, okay? Something in R10, okay? So in mathematics, here, we will look at more general behavior of the linear problem, which is the simplest thing that we can learn, okay? As I told you that normally in the real world, they are non-linear behavior. But to understand the basic thing, we try to go down to something called linear problem. That's why the subject linear algebra is is important for a lot of people who study in science and engineering. Okay, so we talk in R2 problems. Okay. We will discuss about the solution of the linear equation. Okay. I said you will have something that you have two equations that cut only one point, you might come up with something that these two lines are parallel to each other. Or you have one line and then the second line, which is exactly the same. Okay? So it means there are so many solutions for the third case. Now we will look at the first one, which is easy that we have learned it before. Okay, what we try to do is instead of try to reduce the matrix, okay, if we have the system of equation AX equal to B. Instead of reduce this into what we call the Gaussian elimination. Okay, we will reduce this to okay, Ix equal to B. Okay, so this one I call this like from this to this. We call the Gauss-Jordan form. Okay. But sometimes we may not be able to write coefficient matrix as an I. Okay. And I will talk about that later. Okay. Now I will give you example that I will start with quotient matrix A times X. Suppose you have 2, 1, 2. For example, so this one is quotient matrix is A, this vector is X, and this right hand side matrix is B. Okay. So now I will write that in terms of the augmented matrix again. 2, 1, 4, 3, and 1, 1. Here, if I want I will divide it row 1. Okay, I don't want to confuse you. Let me go to you first. 2, 4, 1. And then R2 minus R1 over 2 times 1, right? I want to make this equal to 0. Like Gaussian elimination. But you get 3 minus 1 over 2 times 4, so we get 1 here. Okay. And then 1 minus 1 over 2 times 1 is 1 over 2. Okay. And now I want I, right? So now I go from this one, I have U already. Now, if I want to have identity matrix, I will use this one, the one below here, to make the one above equal to 0, okay? If I want this to be 0, what would you do? R1 minus R2, actually divided by 1, right? And then multiply by 4, okay? So I get this one 0. So to do the calculation, I get R1, which is 2 minus 4 times 0. So it's gonna be 2. And then the other one, we get R1, which is 1 minus 1 over 2 times 1 over 2, which is 1 over 4. 1 minus 1 over 4 is 3 over 4. Okay. Now, is equivalent to I divided row 1 by 1. 1, 0, 0, 1. So you get 3 over 8 and 1 over 2. Okay? Here, what you can say? What is the solution? The solution is x is 3 over 8 and y is 1 over 2. Okay? Right? Because this is gonna be 1x plus 0y equal to 3 over 8. So the right-hand side here is just the solution. The right-hand side is just the solution. Okay. One more. One more example, okay? Mhm. Let me use the one example that would if I want to solve the equation x plus y plus z equal to 3, 2x plus 3y plus 7z equal to 0. X plus 3y minus 2z equal to 17. Okay. So I will write down the quotient matrix is 1, 2, 1, 1, 3, 3, 1, 7 minus 2, 3, 0, 17. Okay. Since this one is 1 already, that's fine. Okay. So now I will make the one below equal to 0. row 2 minus 2 row 1, row 3 minus row 1. 3 minus is going to be what? R2 is 3 minus 2 by 1 is 1. 7 minus 2 is 5. 0 minus 6 is minus 6. And then 3 minus 1 is 2. Minus 2 minus 1 is minus 3. 17 minus 3 is 15. Well, 14. 14. Right? Correct? Uh, 3. Yes, sorry. 3. Yeah. Thank you. So, of this. Excuse me. So now you use this. This one, make it 0. Okay? Excuse me. Sorry, I have sinuses, so it's blocked my nose. Maybe we do one at a time, okay? If this is already 1, I will make this 0 and make this 0, okay? Because the first column is okay already. Now I'm just 1, 0, 0. This is 1. This is 5. This is minus 6. Okay. So I have row number 1 minus row number 2. Row number 3 minus 2 of row number 2. So now the pivot is this one, okay? Whenever we say pivot, it's gonna be play important role in get rid of other things in the same column. Okay. You can see that if pivot is there, the first column will not affect. You will see that it's not affect because row number 1 is 1. 1 minus 0 is still 1. So this first column is not affect anything. So it's gonna be 1 minus 1 is 0. 5 minus 1 is 4. Minus 6 minus 3 is minus 9. And then what? 2 minus 2 is 0. Okay. Minus 3 minus 2 times 5. So it's minus 13. Yeah. And then what? Minus 13 minus 2 times negative 9, right? 18 10 no, row 1 is at 9 or minus 9? 9, right? Yeah. 9, right? Yeah. So it's gonna be plus 9 there. 8 ลบ 13 ลบ 18โอ้ทำไมอันนี้เป็นลบ4เดี๋ยวนะทำไมเป็นลบ4ไม่ sorry R1 minus R2 oh 1 minus 5 equal to minus 4 sorry R1 is 3 minus 6 equal to 9 okay and then this one is R3 which is minus 3 minus 2 times 5 which is minus 13 and then 14 minus 2 times minus 6 right R2 okay 2 เป็น26 26 okay that's correct and now I make this number equal to 1 R3 divided by negative 13 okay so this gonna be 1 and minus 2 is that correct yes okay now I gonna make this and this equal to 0 by using this as the pivot R2 minus 5 R1 R3 right we want to use 5 by using this pivot is 1 already so it's going to be 5 minus 5 of row number 3 and row number 1 minus 4 times R3 so it's row number 1 plus 4 R3 okay so this is going to be 0 and 0 for sure okay because we force it to be 0 okay so what do you have minus 9 plus 9 plus 4 times negative 2 1 in minus 2 no minus 6 minus 5 times minus 2 10 4 10 minus 6 is 4 okay so from this case we will say that x is 1 y is 4 z is minus 2 okay so this is called the Gauss-Jordan form okay Okay. New word, new vocabulary. Okay. So we want to check the matrix. If your matrix is called the reduced row echelon form. Okay. So I will say that in row echelon form, reduce is when the leading element in each row is 1. Okay. So I will say that I have to say that row echelon form first. Okay. Do you see the matrix over there? Okay. By showing example is easiest. Okay. I will say that the matrix is in the row echelon form. If the matrix, okay, the first thing you look at it, if the 0 rows, if the entire, every element in the row has 0, okay, it has to be stay in the bottom. It's less priority. You push it down to the last row. Or if it have 2 0, you put it underneath the bottom of the matrix. Okay. So it's gonna be that all rows having only 0 entries are at the bottom. Okay, like this. You plug in the 0 in the bottom. Okay. Number 2, the leading entry of every non-zero row, that is called the pivot, is on the right of the leading entry of every row above. It means that the pivot is the first non-zero element in the row. Okay. Okay. The first one is the pivot. Okay, the leading element in each row. This one, this is the first row, no problem. Now, which is the pivot? Second row, this is the first one that is non-zero. This gonna be shift to the right, okay, of the above row. It means this is stay on the right of the above row. Here you go first, second, third, fourth column. So now the pivot is below this one and to the right. Okay, shift to the right. Okay, of the first pivot on the above. Okay, so basically you think about the step. Okay, it just go this way to the diagonal, or it's off the diagonal, it's okay too. It's like this. Okay, 0 is always stay in the bottom. Okay, so this is called the echelon form. And if I say the word reduced row echelon form, the only this thing or the only difference is instead of number 2 as the pivot, it has to be 1. That's first add the word reduced row echelon form. Okay. Here, this matrix 0, oh, this matrix 0 stay on the bottom. Row echelon form Zero stay in the bottom. And the pivot on the bottom stay to the right of the matrix. But if it's called the reduced row echelon form, the pivot has to be 1. That's it. Okay. So the identity matrix. So this is the reduced row echelon form. Okay. Why is that? Look at first, are they any row that has all entire 0? No. Okay. Now the first row, the pivot element here in the first row is 1. And the second row is in the second column, is shift to the right. Third row is shift to the right, so matrix I is in the reduced row echelon form. Okay. Now, so it is row echelon form. This is row echelon form. First, 0, stay on the bottom. Check the first row, number 1 pivot is here. And second row, the first pivot shift to the right of the above. So this is the row echelon form. But if I say this is reduced row echelon form, say no, right? Because this is 2, it's supposed to be 1, right? Okay. If it has to be 1, if we put the word reduce, it means reduces to 1. Okay. So, but is it possible to make this function to be reduced row echelon form? Yes, of course. You divide it by 2, right? Okay. So this is what we call the reduced row echelon form. Okay. So in the matrix, when we try to reduce, okay, let okay, fine. So is this matrix is in the reduced row echelon form? You think so, okay? So you don't need to do anything, okay? But if I have this, okay, this system, if this system is the augmented matrix of the system AX equal to B, okay? Okay. So X is composed of X, Y, and Z. So I will put this, okay? I just from this reduced row reduced echelon, this is in the row reduced echelon. I want to write down the solution. I want to write down the solution. So you can see that from this one, if you write that, it's already in form of the reduced row echelon form. And now I will rewrite this in terms of the equation. Express this from the matrix to the equation. I will get this as x plus y plus z equal to 1. And then y plus 2z equal to 2. Right? I have x, y, and z. But my unknown is r, x, y, and z. So we have 3 unknowns. We have 2 equations. So I will write down in this case, I will write down that from the second equation, I will say that y can be written as 2 minus 2z, right? Y will always equal to 2 minus 2z. And then z can be anything, right? Can be any real number. Whatever you plug in z, you get y. And then how about x? X gonna be 1 minus y minus z. But y can be written in terms of 2 minus 2z. Okay, so you will have negative 1 plus z. So again, C is already stated here, okay? The same thing. Z can be anything. F is gonna be whatever the number you plug in Z. So I will say that example that if I choose Z equal to 1, X is gonna be what? Minus 1 plus 1 equal to 0. And Y has to be 2 minus 2, which is 0. So the answer is vector X, one of the solution is 0, 0, 1. Okay. You can check if I have plug in x0, y0, c is 1. y0, c is 1. Okay. And if I say z equal to 0, can I do that? Yes. Z equal to 0, I will get y equal to 2, x equal to minus 1. So you have another solution, which is minus 1 to 0. Or one can say z is 0.5. Can you do it? Yes. Okay. And you will get values of y equal to 2 minus 1, which is 1. And z and x, sorry. Yeah. X is minus 1 plus 0.5, which is minus 0.5. Okay. So you have different number depend on the value of z. And z is in real values. is so many things. So this, if you have the type of the reduced row echelon like this, you will have infinitely many solutions. Okay, this explains why you have two lines just exactly the same. Okay. But this one is like two plane which on the top of each other. Okay, it's just one plane that satisfy the property this and this. Okay. Let me introduce you to the other reduced row echelon and then we're done for today, okay? So we have 1, 0, 2, 1, 0, 1, 1, 3, 0, 0, 0, 2. Now I want you to look at the coefficient matrix. This is in the, only this part, okay? It is in the reduced row echelon form already because 0 below the bottom, number one, and this one shift to the right. So this. But this type of problem, do we have the solution? Is it possible to get the solution? It can't be. Why is that? Because the last row. This is the problem. You have 0x plus 0y plus 0z equal to 2. Impossible. Okay? So, no solution. Okay? So, this is the three types. Okay? We try to reduce the system of linear equation, satisfy the reduced row echelon form. Once we reduce it to the row echelon form, we can see if you have unique solution, you have the only one solution like this or not, okay? Or if it like this, you have more unknowns than your equation. You may have infinitely many solutions. There's so many solutions depend on the values you pick. Okay, there are so many. And the last type is impossible. You cannot make 0 equal to something. Okay, you cannot force nothing to be something. Okay, so this is all the three cases. And this can be extended to the high dimensional. So this is the introduction of the linear algebra and the solution of the system of linear equation. Okay, so I will see you on next week and next Monday. 3 more classes. Okay. Only 3 because on the 8th, no class. Okay, on the 8th, no class. And I will give you the homework problem, which is the review problem. Okay, after that, I will give you the solution key. Okay, the exam gonna be similar to the practice problem, except changing something. And we have just one difficult problem or more challenge problem to split or separate people from A, B, and C. Okay, so this is just gonna be, if everybody can do it and understand the procedure, the steps, I think that everyone can pass the course, okay? Because I think if you review it, more than 60% of the grade you can get. Okay, we'll see you guys next week. Okay.